Now what we will do today is we will do some demonstrations related to another very exciting IoT protocol, and this broadly forms, the name of this protocol is AMQP, Advanced Messaging Queuing Protocol. This is open standard again, and it supports both point to point as well as publish subscribe models, routing and queuing. Okay. Without any delay, let us start with the demonstrations and then we look at all other related things with respect to the protocol. What I have on my my extreme right is the publisher. What I have here is what is known as a broker. Look at the name, it is called Rabbit MQ, and this is the subscriber. Okay. And unlike MQTT, where basically there is a topic and there is a broker to which you subscribe or publish to the topic, AMQP is a little different compared to that. Basically all producers write to what are known as publish to what are known as exchanges, and the exchange depending on what is given in the routing queue, that exchange will intelligently give it to different queues. Okay. So the routing key is an additional thing. In fact in MQTT the routing key itself was in a way the topic, right, and if someone had subscribed to it, it was just going there. You will not be doing that anymore. You publish to an exchange and the intelligence is from the exchange to the queue, which is dependent on the routing key. Alright. So to understand this better, let us start the demonstrations. The first demonstration that we have here is on the left side. Two of our colleagues Tejaswini and Abhirami will start the demonstration. What we will do is, you observe here carefully that there is a queue by name queue test, and do not worry about what type of exchange this is. This is one type of exchange where producer can directly write to the queue, right. So he is actually doing that. So now she will type in the message which says Python send default.py, that is the script name, welcome to IoT, that is the what the producer is trying to push to the broker. There it goes. Alright. So you can see here that this count should really go up by 1. You see that it has gone up by 1. Why is it not 0? Why is it 1? Because the consumer was offline. The consumer did not want to pick it up because for some reason he is not online. Now if he comes online, the consumer should get this message, right. So let us do that and see what actually happens. You can see that welcome to IoT, what was published by the producer, actually come here, and the queue test has become 0. So this is one type of exchange essentially which will allow you to produce data and have consumers in this data. Now how did we set up this network? This was set up by it is connected wirelessly, and basically you can replace these laptops that you have with handheld devices like mobile phones, and basically have AMQP running also on very small devices. These three are wirelessly connected. There is an access point that has been placed here, and this access point is providing connections between these producers, producers, broker and the consumer. The same model of producer not being in direct contact with the consumer continues to be an important thing, quite similar to that of MQTT. Stop. Alright, so let us move on and see another demo. Subtle differences, but you have to note it very carefully. What we did earlier with the producer was we ran what is known as a script, Python script, where we were invoking a direct type of exchange. Okay. Now what we are going to do is we are going to use fan out exchange. Fan out exchange simply means one to many. Now where are many here? The consumer has, we have invoked two consumers here just to show you that the one to many actually works. And to see how that is done in a script, let us try more, just try opening that script, Tejaswini. Let us do just open, just let us see how the script looks. Yes, you can see that the name of the exchange is logs, and that appears here, right. You can see logs, and you can also see that this is a fan out type of exchange, which essentially means one to many, and the type is mentioned here as fan out. Okay. So this is the key thing. So if she types a message here, it should go to many, and we should see the logs name of the exchange actually incrementing that. So let us try that. So we have now given Python send fan out hello user 1, right. So that is what has happened, and you can see that it has appeared for user 1 and it has also appeared for user 2. So this is a mini demonstration of the capabilities of Rabbit MQ, which essentially is implemented based on the advanced messaging queuing protocol. So what I wrote on the screen is Paho client, Mosquito server and mosquito.conf being the main file. All this was with respect to the MQTT, right. And now we will have to move on and also cover sections related to another IoT protocol, very famous IoT protocol, and a very I would say robust one, and this is called AMQP, as I already mentioned to you during the recording of the video. Now you must note that if you have had a Facebook account, you would have actually used MQTT, because the messaging in Facebook actually uses MQTT, and if you have had an Aadhaar card, the messaging protocol is one of the finest examples of what is free open source software, right. And AMQP is the messaging part in Aadhaar card. All of this means that these, either if you take either MQTT or AMQP, all these are application layer, very important point, application layer binary protocols. Okay. Why is this important? Because these are meant for machines to read, machines to generate, machine to generate data and machine to read data. You do not want humans to actually look up anything here. Things have to happen between machine to machine. Please recall that I mentioned to you that in the IoT world it is about thing to thing communication, right, thing to thing and not human to thing, which is anyway a small part, or human to human, which is all very well known. Thing to thing essentially means that unless it is a binary protocol, compact and terse, because it is not interpreted by humans, it can be as terse as possible. So it is compact, terse, and that is how you get a lot of nice compression, automatic compression, because it is no, I would not say compression, I would say it is compact, right, it is compact. That compactness comes directly because of the fact that it is a binary protocol. So moving on, how does the whole thing how does AMQP look and compare with that to the other well known pub sub? Let me draw a picture. Essentially a AMQP equivalent broker will actually have two parts. One is the exchange. Okay, so it is written EX, okay, like this, and then there are what are known as queues. You can imagine something like this. Okay. I mentioned to you about the type of exchanges, direct exchange, fan out exchange and so on. So these are the publishers. And these are basically subscribers. Okay. So this essentially forms the mechanism in AMQP, right. So you can say that this is a message oriented protocol, and there are message delivery guarantees, starting with at most once, at least once, as well as exactly once. The QoS levels, which we know very well, are also applicable to this protocol. Okay. So that is one thing. The message format appears a little strange, and maybe I should quickly write down how it looks. Basically any message will have a header and a footer. So let us put down the header and footer. There are what are known as delivery annotations. So this can be typically a delivery annotation, and this is a message annotation. Okay. Then there are also what are known as fields for bare message. So you can have bare message. So this is a bare message. As well. So essentially what you see here in this picture is the fact that both bare message as well as annotated message are possible within the message format of AMQP. and it is so this messaging is on top of a transport layer. Okay. The messaging capabilities are handled, all possible message and capabilities are handled in this layer, and AMQP, as I mentioned, has these two types of messages. These bare messages are basically those that are supplied by the sender, those which are supplied by the sender, and annotated messages those which are actually seen at the receiver. These are all seen at the receiver, seen at the receiver. Oops, looks. Anyway, this is important, at the receiver, seen at the receiver, at receiver. Okay. Now, the header in this format actually conveys the delivery parameters. That is interesting, right? It conveys all the delivery parameters. Okay. So, what does it mean? It means durability, then priority, time to live, okay, first acquirer, and also finally delivery count. All of this is there in the header part. Okay. The transport layer provides the required extension points for the message layer, and in this layer the communications are all basically frame oriented, and there is again a structure for the AMQP frames which I will not draw, but there is indeed a structure, and this structure is what is well defined in the standard. So, I think basically if you understand that AMQP is also has the ability of using publish subscribe in addition to other methods of delivery. It is not only just about broker, publish and subscribe, but it is more than that, in the sense that it is both point to point, publish subscribe model, routing, queuing and so on, right. So, that is the key thing here. So, often we are asked this question, right, what is the comparison of MQTT and AMQP, right. This is what people keep asking, and I think it is quite natural that you should understand major differences between them. Well, both are IoT protocols which you should know, we have already said that. MQTT is more like, I would say, low overhead, it is more like a low overhead, simple, very simple to implement, both for sending data, for receiving data and so on. AMQP is you can say is more like as heavy as HTTP, and I would perhaps even call it is perhaps the asynchronous version complement, I would say, of complement to HTTP. You can say more or less like that. See, the good thing about both these is that they are very cloud friendly. Remember our initial introduction to IoT, we did talk about storage, and we did talk about a cloud server, and in the cloud, on the cloud systems, if you wish to run MQTT or AMQP, it is quite easy to install them on cloud systems. So, they are very cloud friendly. So, cloud computing for instance becomes much simpler. The message queuing with its asynchronous nature, basically the message queuing part and this fact that it is asynchronous, right, part is a perfect for interoperating many different environments. It is a very perfect, allows you for lot of interoperating with different environments. So, that is really very good, right. So, all of MQTT if you take, I will flip between MQTT and AMQP as we keep explaining, everything around MQTT is about this topic, and topic itself is like a single namespace, right, it is a single namespace. And you do not have for example one major I would say shortcoming is that store and forward is not known to MQTT. There is nothing like store and forward, and there are nothing like queues, no queues actually. If you have a queue, then you can associate it with sorry about this. So, because there are no queues, store and forward is not there. Okay, so, if this is not there, what is the big deal? Multi-tenant or tenancy becomes an issue. If you do not have these capabilities. In other words, a single piece of software serving a set of hosts, the single instance, not set, a single instance of AMQP can serve a set of hosts, and that is what will give it this multi-tenancy feature, which is not possible in MQTT. You have a single broker, all of them connect to that broker, right. So, that way AMQP is quite a multi-tenancy approach is there, and multi-host also is possible, multi-hosted. So, you can just imagine how much it will scale when we work with multi-hosting. Multi-host capability also is there. So, this is a big thing in AMQP. Further things are, this is not really a company driven, which one, AMQP, it is more customer driven paradigm, that is the key thing. And if you look at any major big large projects and corporates, you will find that it is all about AMQP installations, but hardly you will find anything in the MQTT space. So, that is the another important thing, which is quite obvious from the fact that the standard is open, and also the fact that Aadhaar card was actually using it, right, is actually using this as a messaging protocol. Okay, so that is important. If you turn back to MQTT again, if you go back and look at what MQTT does, it is mostly for small I would say small devices. It is meant for small devices sending small data over constrained links, right, over low bandwidth links, but AMQP full messaging scenario is possible. So it is really exhaustive in that sense. Okay, so MQTT I would say is more, I would say, stream based. I would say it is a streaming methodology, or rather it uses streaming. So when you say it is stream oriented, it is sort of agreeing with constrained devices where you have low memory, right, you have low memory, and this low memory client essentially low memory device is quite amenable to this stream oriented protocol, whereas AMQP it is a buffer, it is more like a buffer oriented. It is more like a buffer oriented approach. Which means you can have high performance servers. And MQTT, you can't really split a message into two parts, whereas AMQP says okay, I can take a message and sort of allow it to transmit large messages even on constrained environments. So MQTT says no fragmentation, no fragmentation. As against AMQP, it says no problem. See, the trouble with MQTT broker based approach, you have a publisher and you have a subscriber. You can be offline for a while, for a short while, but by and large it assumes that both are online. It assumes that both are really online. So long lived messages do not exist, in MQTT. Okay. Whereas again coming back to AMQP, this guy is any form of messaging is fine. Okay, you can be talking about classic message queues, round robin, right, store and forward, and combinations. All of this is possible. So, what this actually means is some customers can get copies of messages while others pull straight from the same queue, that is possible. And the filters are powerful. You have filters are powerful, I would say, unlike MQTT. So, you could apply very nice complex rules which form like filters, and you can extract data, you can pull the data from them. So, that makes it very interesting and very exciting protocol. And AMQP has another advantage, that it is it basically likes a transaction. It likes to get into a transaction mode, is possible in AMQP, whereas with MQTT you do not have this possibility of a transaction. We will discuss security and other related features as we go along in our next class. Thank you. So, let us do a few more demonstrations of AMQP, and let us understand all the possible exchange types which are there, at least two other important exchange types which will give you an overall idea of how AMQP can be configured. I want you to draw your attention to the picture I have drawn here, where we go back and show you the standard picture of a publish subscribe architecture. Out in this picture what you see is a producer, which you can see the nice thing about it, that the name has been changed to a producer and a consumer, right. So, they call them producers and consumers instead of the publish subscribe, which we know very well in the MQTT paradigm. Essentially, producers always give it to what is known as an exchange, and there is an exchange name associated with it. There is a queue to which this data goes from the exchange, and then there is a binding which you specify between the exchange and the queue, which is a very critical thing, and then there is a queue name as well, right. And then there are consumers who are essentially IoT devices. So, what are the type of exchanges which are names of different types of exchanges which are possible? The type of exchanges, you can have a direct exchange, you can have fan out exchange, you can have topic exchange, and you can have header exchange. Let us go one by one. We completed direct exchange in the previous demo, but what we would also like to show you is the nice possibility of direct exchange round robin scheduling. Okay, you can do a round robin kind of data, let us say giving data, or for consumers data can be served in a round robin fashion. In other words, the first data packet that arrives from a producer can go to consumer 1, and the second data packet from producer can go to consumer number 2, right. So, this is something that allows you, we can see that demonstration of round robin. Now, with relation to name of exchanges and so on and so forth, well, fan out, as I already described to you last time, is like a simple thing which is a broadcast based system, which essentially means that it does not really matter what you give as an exchange name. In fact, you do not even need to specify the queue name, it is just sufficient if you specify the name of the exchange, because it goes to all consumers moment they are connected to that particular exchange, it simply connects to all. So, it is like a one to many broadcast fan out. Okay. Now, regarding topic exchange, this is an interesting thing that you have to note, is that the binding key and the routing key should actually match, otherwise it will not get delivered to the consumers. However, there are possibilities of using the wildcards that we know very well, and such wildcards include the hash and the star, which is something you can actually exploit for when you set up the whole AMQP architecture. Header exchange is something I want you to explore all by yourselves. It is also an interesting thing, and so we will not be able to spend much time doing a header exchange. So now let us move on to understand from a code perspective how exactly these things actually are specified. So essentially you have to keep the name of the exchange, direct, fan out, topic, header in mind. You have a type, you have the routing key and the binding key. So if you fill up this table, then you are more or less done, right. So that is the key. Now let us first start by by showing you the first script that I would like to show you. In fact, Abhirami and Tejaswini are right here. They will demonstrate default underscore py, right. This is the name of the file, and they will show you something with respect to the direct exchange. It is good to know what goes inside this Python script file. I must tell you that the AMQP producer consumer code is Pika. We have used Pika. I think you can pick it up from the web. It is in, I think, in open source. So you can just take Pika, P-I-K-A. So go to Pika and you can use these scripts. So direct exchange, let me recap. From a producer's perspective, you do not need to specify the name of any exchange, no exchange is required, alright. So I think we will just go and see the demonstration, and I will perhaps mention to you as we go through the demonstration what are the key things to look out in those particular Python scripts. So let us start by showing you some scripts on the producer side. So let us take the first script which is on the producer side, and so let me move this. So this is the producer, what you see in the middle is the consumer, the rabbit broker, which has also support for the exchange, and another host which essentially is able to which is basically a consumer. You can have multiple instances of the consumer. Let us focus right now on the producer side. So I will ask Tejaswini to type in the default.py, which is essentially the direct exchange. Let us open that file. So now what we will do is we will start looking up at all the scripts from the producer side. One by one we will go, and I will explain to you the important things in these scripts. Use Pika as I mentioned to you, open those scripts and modify them accordingly. You should be able to set up a quite simply the AMQP, both producer, rabbit MQ as the broker, which also has the exchange, and consumers, alright. Remember that AMQP is basically customer driven, not any company driven system. So it is a much more powerful, much more scalable and robust publish subscribe architecture, not just limited to publish subscribe but also about routing, which I mentioned to you, right. So let us move on. Default, so we will first show you the direct exchange. So let us open direct exchange. Direct exchange is you can see is default.py. Here what you should look out is that we have not actually specified any exchange name, right, but a queue name has been specified. In fact, you can see that it is called queue test, okay, and in fact this whatever is being published can also be published to test underscore queue, which is also shown there. But never mind, if you have a consumer which connects to queue test, he will pick data from queue test, but producer says I want to give it to both the queues, both queue test as well as task. Okay. So, that is about the default.py. Let us clear this screen and let us try the round robin part of the direct exchange. So, now we go for round robin, open, again you can see that no name of the exchange is specified. The queue name is specified here, which is task queue, and what is important is that delivery underscore mode, which has been set to 2. This means that indeed it is round robin. Alright, now we clear the screen again and we go and show you complete the thing on fan out. In fan out, look out for the name of the exchange. You can see type is equal to fan out is mentioned. Recall the table I put in the slide where I want you to fill up. So, essentially type is equal to fan out means it is the name of the exchange, and you do not need to specify any routing key, only the queue name is also specified, and the queue name here is task underscore queue, right. So, that is the name of the queue. Alright. So, now let us clear again and now open up topic exchange, right. Here again what is important is the exchange name is required. Okay. So, you can see the name of the exchange here is topic underscore logs, right, and this is indeed a type which is topic exchange. So, that is also indicated quite clearly there. You do need a routing key, right. So, you can see that the routing key has been specified as routing key is equal to the routing key is specified here as routing key is equal to underscore routing key, which means binding key which will come as an argument while we type will be taken, and that will be given to the routing key. So, the binding key and the routing key have to match, essentially that is the key requirement in the topic type of exchange. Alright. So, now these are the most important thing here, and this completes the type of the number of scripts that we look up at the producer side. Now, let us shift and see what actually happens at the consumer side. Alright, now this is the screen which is on the consumer's side. We will start by looking up at the direct exchange, which is given by the script name receive underscore default.py. Let us open that, and now Abhirami shows us that what is very important is the queue name which has to be specified, and just you have to look out for that. Okay. The rest of it is a standard thing. So, let us clear this, and now let us move on to see the same direct exchange, but this time round robin. Again you should look out for the queue name, right, which you can see there is channel underscore dot queue underscore declare queue is equal to task underscore queue, that indeed is the queue name, right, very good. So, that is about direct exchange. Now, let us do clear screen and let us try fan out. Okay. In fan out, what you should look for is the exchange name, and you should also look out for the type which is equal to the fan out. The name of the exchange is logs, as you can see there, and the type is fan out. Now, finally I will do a clear screen again, and then we will open the topic exchange. We will open a file which is called topic exchange. Here what you should look for is the exchange name, which is topic underscore logs, and you should look at the type, which is actually the exchange type is called topic. What you should really look out for, which we actually mentioned at the producer side when Tejaswini was showing the demonstration, Abhirami points us to another important line in the in this consumer side, which corresponds to the routing key equal to the binding key. This is the point really that you have to specify at the consumer side, which is quite obvious, right, and that becomes the binding key becomes an argument when the producer is actually pushing out data, and that is how producers and consumers are connected via the exchange and the binding between the exchange and the queues which are associated. Now what we will do is we will quickly so this is mainly what we can show you in terms of scripts, but a real demonstration would mean that you should actually practice by yourself and see how exactly it happens, because it has to pass through the broker.